All right, for this question, we are asked, if a boy rolls a die twice, what is the probability that the die will land on a 6 both times? Okay, so the skill is compound probability. We'll come back to that skill towards the end of this discussion of the question. But first, we're going to talk about the strategy, create an organized list. Let's think about the things that could happen as he rolls the die. So he's got a die, he's going to roll the die. Think about what could happen. So it could be 1, 2, 3, 4, 5, or 6. So those are the only options. But then he's going to roll a die twice. So he's going to roll it again. Think about what could happen this time. And again, it could either be 1, 2, 3, 4, 5, or 6. So let's make a list that shows all the possible things that could happen. Now, when you make the list, you could say, well, first he'll get a 3, then he'll get a 5. Maybe he gets a 6 the first time, and maybe he gets a 1 the next time. Maybe he gets a 4, and then another 4. Now, I could keep doing this. The thing is that this is not organized. And so if I try to list all the possible outcomes like this, I'm probably going to either duplicate some or forget some. So what we want to do is create an organized list to make sure that we get all of the things that could happen and that we get exactly the right amount of things that could happen, the total possible outcomes. So instead of just random numbers like that, I would start with a 1. He could get a 1 the first time he rolls the die, and then he could get a 1 again. Okay, so since I'm trying to be organized, I'm going to stick with a 1. He could get a 1 the first time he rolls the die, and then he could get a 2. I think you see where I'm going with this. He could get a 1 the first time, and then a 3, a 1, and then a 4. I'm going to stick with all the possible things that could happen if he rolls a 1 the first time. Okay, he could get a 1 and a 5. He could get a 1 and a 6. Okay, those are all of the outcomes that could happen if he rolls a 1 on the first roll. But maybe he doesn't get a 1 the first time. So where do you think I'm going to go from here to create this organized list of all the possible outcomes? Okay, I'm just going to go in order. I'm going to say maybe he gets a 2 on the first roll. And then he gets a 1 on the next roll. And then a 2 and then a 2. Or he could get a 2 and then a 3. A 2 and a 4. A 2 and a 5. A 2 and a 6. All right, let's keep creating all of the different outcomes that could happen, but again, we're going to stay organized. So sticking with the organization that I've already started, what do you think the next thing that we should write down would be? He can get a 3 and then a 1, a 3 and then a 2. And we can keep doing this. So let's go ahead and list all the possible outcomes, sticking with this organization. All right, so here we go. So we've got all the possible outcomes. Continuing with all the things that could happen if he rolls a 3 the first time, and then what about if he gets a 4 the first time? 4, 1, 4, 2, 4, 3, all the way down to 4, 6. Same thing with 5, 1, 5, 2, all the way down to 5, 6. And he could get a 6 and then a 1, 6 and then a 2, 6 and then a 3, all the way down until it's 6 and then a 6. So now we stayed organized this time, and we could count all of these different outcomes. If you count them all together, there's 36 total outcomes here. So if you remember, when we're talking about probability, the total amount of outcomes is listed as the denominator in the fraction showing the probability. So it's going to be something over 36. So again, we were asked to find out what is the probability that this boy rolls a 6 and then a 6 again. So out of all of these different outcomes, let's see how many are a 6 and then a 6 again. So the only one that's a 6 and then a 6 again is this one right there. That's a 6 and then a 6. No other possibility is a 6 followed by a 6. So that's only one chance out of all of these chances. So we've got 1 out of 36, and there's our compound probability. All right, so let me show you another way that we can get this with a shortcut, understanding compound probability. Now, if you don't know the shortcut, then again, creating an organized list is the way to go, just like this. All right, here's the shortcut. If you want to get the probability of rolling a 6 and then rolling a 6 again, what you can do is get the probability of each event and then go from there. So what I'm saying is this. Forget about this roll. Just focusing on this first roll. What is the probability that I could roll this and get a 6, or this boy could roll this and get a 6? So there's 6 possible outcomes. How many of them are a 6? And so there's, out of 6 outcomes that could happen, only one of these is a 6. So it's a 1 out of 6 chance, or a 1/6 probability of that happening. Okay, now, forget about that first roll, only focus on this roll. What is the probability that this time I'm going to get a 6? And once again, there's 6 possible outcomes on the die. Only one of them is a 6, and so I'd have a 1 out of 6 chance of getting a 6. So you find the probability of the first event, you find the probability of the second event. If you want the probability that both of those things will occur, you find their product, you multiply them. So you've got to do 1 6 multiplied by 1 6, and that will give you the probability of both of these things occurring. 1 times 1 is 1, 6 times 6 is 36, and there's the compound probability. Notice it's the same answer that we got when we made the organized list. So if you're trying to solve this problem and you don't remember the shortcut or you don't know the shortcut, then make an organized list for yourself so you can actually visualize all the outcomes and see how many are the ones that we're talking about. But if you know the shortcut, then that's the way to get that answer a lot faster. Compound probability.